Welcome to this explainer. Okay, today we're diving into something that's honestly a bit of a wild ride. We're talking about the massive paradigm shift happening right now in AI quality assurance. If you've spent any time evaluating software, you are totally used to a deterministic playbook. But AI? Well, AI is a probabilistic frontier. And let's be real, it kind of requires a total brain transplant for anyone working in QA today.
Just picture this scenario for a second. You sit down, you open up your standard test case template, you diligently write down your preconditions, you list out all the execution steps, and then you get to the expected result field. And you just stop. Because what exactly is the expected result? Honestly, how do you even test software when there is literally no single right answer? You could run the exact same prompt twice, and the AI is going to give you two completely different yet somehow perfectly reasonable answers. The cognitive dissonance testers are facing right now is just immense. That one comfortable thing we've relied on our entire careers, a known single correct output, is completely gone. So here is our roadmap for today. First up, the AI paradigm shift. Second, we'll meet the new bugs. Third, we'll dive into the new testing playbook. And finally, we'll wrap up with the human advantage. Let's get right into it.
Part 1. The AI paradigm shift.
Traditional software testing is incredibly straightforward because it's purely deterministic. Input X literally always equals output Y. You click Add to Cart, bam, the cart count goes to 1. You try to submit a blank form, you get an email required error. Simple, right? But AI testing is probabilistic. Because an AI prompt generates slightly different wording every single time you run it, you just can't assert an exact string match anymore. It doesn't work. Instead, what you have to do is define acceptable boundaries and thresholds. So you're no longer checking for an exact match, you're checking to see if the output is behaving safely within a predefined set of rules.
And this fundamental difference, the industry actually has a formal name for it. It's called the oracle problem. See, in normal software testing, an oracle is your single, clear source of truth. It's the thing that definitively dictates whether a test passes or fails. But with AI, that single source of truth doesn't exist. You can't compare the system's output against a known answer because the AI is creating a completely novel response every time. So what do? Well, you have to lean entirely on your own domain knowledge, statistical precision, and behavioral guardrails just to figure out if the system is doing what it's supposed to do.
Which brings us to Part 2. Meet the new bugs.
Because here's the thing, we aren't just hunting for your standard 404 errors or application crashes anymore. Now, we are hunting for completely plausible yet totally factually incorrect statements. Let's walk through these new culprits. First up, we've got hallucinations. This is when the AI confidently states an absolute falsehood, like completely inventing a fake refund policy for your company. Not great. Next is hidden bias, which is where the model secretly treats equivalent demographic groups unfairly. Then we have ungrounded confidence. This one is super tricky because the AI's incredibly polished authoritative tone actually masks the underlying errors. And finally, model drift, where the system's accuracy literally degrades over time.
And speaking of model drift, grab a hold of this statistic, 91%. A shocking 91% of machine learning models actually degrade over time if you aren't constantly testing them. In the old world of traditional software, testing usually wrapped up once the code hit production. But with AI, the real world is constantly changing, while the model is just sitting there staying exactly the same. If you aren't testing it continuously, your model is going to silently degrade and become a massive liability for your business.
To put this into a bit of perspective, let's look at some data from the Stanford AI Index. It really gives a powerful quantitative punch to just how common these hallucinations are. Across 26 leading models they tested, the absolute best performing model out there still had a 22% hallucination error rate. That means more than 1 in 5 times it's just making things up. And the worst performing model, a staggering 94% error rate. Honestly, this proves that AI can be confidently wrong at a really alarming frequency. And trust me, no automated stack trace is ever going to catch that for you.
All right, let's talk solutions, section free, the new testing playbook.
So how do we actually do this? First, you've got to probe with knowns. Ask the AI questions where you absolutely already know the ground truth. If it gets it wrong, boom, you've caught a hallucination. Second, ask it something it literally cannot possibly know. You want to see, does it admit a gap in its knowledge or does it try to invent a fake answer? Third, you need to run the exact same input 5 to 10 times. I know it sounds tedious, but a single test run tells you almost nothing when outputs are non-deterministic. You have to read the spread. Fourth, push the edges. Feed it total gibberish or give it contradictory instructions just to see if the guardrails break. And fifth, please check the receipts. If the AI hands you a citation or a link, you've got to click it. A hallucinated citation looks exactly identical to a real one.
Okay, let's look at a vivid, real-world scenario to see how we hunt for that hidden bias I mentioned earlier. Imagine you're testing an AI feature that evaluates candidate resumes for an HR department. For one candidate, output A says, strong candidate, recommend for interview. But for another candidate, output B says, adequate candidate, consider other options. So the question is, what caused the AI to change its recommendations so drastically?
Well, this perfectly illustrates a really clever technique called equivalence swapping. Notice the variables in this table. We took the exact same resume, literally identical education, identical skills, identical experience. The absolute only attribute we swapped was the name, from John Doe to Jane Doe. And just by changing that one completely irrelevant demographic attribute, the AI's recommendation dropped from strong all the way down to adequate. This right here is exactly how you uncover hidden demographic bias. And notice, no script could ever write this test case for you, because no automated script inherently knows how to catch contextual, nuanced human variable.
Which brings us to our final section, Part 4, the human advantage.
Because here is the crucial reality of the situation. AI models simply cannot reliably evaluate their own outputs at the level of nuance that the real world requires. They just can't. They can't look at a response and reliably understand the compliance risks or the real-world implications or those subtle nuances of human context we just talked about. Companies are quickly realizing that to deploy this stuff safely, they absolutely must pay real people to exercise human judgment over the AI's outputs.
And what this means for you is a massive career opportunity. Seriously, AI testing is not here to eliminate your job. It's here to elevate it into a highly lucrative, highly strategic position. Think about it. A traditional manual tester evolves into a prompt engineer, expertly crafting inputs to expose those weird edge cases. An automation engineer becomes an AI test supervisor, managing entirely self-healing testing frameworks. And the QA manager? They step up into the role of an AI testing strategist, navigating the big business risks and defining the testing boundaries for the whole organization.
So I want to leave you with this final thought. As we look ahead at a future where AI can literally write the code and generate the scripts, who actually determines if that system is safe, fair, and reliable enough for us to trust? The answer is you, the human evaluator. You are the final gatekeeper in this entire AI quality revolution. So keep questioning, keep probing those boundaries, and I absolutely cannot wait to see you in the next explainer.